All right, for today, it is transforming log functions and then graphing them. And the other one that's probably more complicated is I give you a graph and then you have to tell me what the log was. Like if I just said, here's a log graph, what's the equation? Definitely harder. So there's a couple things to learn today, but I still would say it's an easier than usual day. All right, would you agree that that generally looks like the log graph? You remember I said it kind of looked like a tree that's been blown over? Okay. And I made a dumb dad joke about how that's kind of like a log. All right, so if this is at 3, do you agree that the asymptote's normally at the right, like right here, and which would be 0, and it's over 3? Do you get the whole thing as moved 3 to the right? So then if this had been back in its normal position, y equals log base, and it could have been a base 2 or a base 3, but it's been moved 3 to the right, how would you do that? This can't be the equation. This black equation I just wrote can't be the answer because it's been moved 3 to the right, and I don't see that in the equation. Sexton, what would I do to make this correct equation?
Do minus 3 on the inside.
Minus 3, that means 3 to the right on the inside, so I'm putting it in parentheses. Do you get, if I didn't have those parentheses, that 3 would be on the outside and it would therefore be a move down? Let me show you what I mean. If I did it wrong by accident and just said log base 3 of x minus 3, do you get that means the whole thing went down 3? So all this would take is the parentheses in the wrong spot, and this moves inside. And remember, it's horizontal on the inside. Stuff on the outside, that would be vertical. And that would mean the whole thing got moved down 3. All right, so here's a typical question that kind of sums it all up. If you can do this, you would totally be fine on this test. So let's talk through, is this a log that's been moved and stretched and stuff? Yeah, so what has happened to it? Number 1, 2, 3 things have happened to it. It's gotten vertically this and vertically that and horizontally that. You can use V and H for vertical and horizontal. What are the 3 things that have happened to it? George, name one thing that has happened to it.
Moved right 1.
Yes. And whether or not you start on the inside or the outside, you have to pick. And he obviously decided to start on the inside. Now that we're done with the inside, now we can move to the outside. So this 2 here, some bold person, take a stab. What does that do? And hint, use the word vertical in your answer. Yes?
Vertical stretch by factor.
Vertical stretch, BFO by a factor of 2. Very nice. And Riker, that negative.
Vertical reflect.
Vertical reflect, yes. Now, some people will, on the test, they may tell you, by the way, it was reflected over the blah axis. I want you to picture what a vertical does. Does it reflect across the X or the Y? The reason is not because I would ask you to say that. I would have been fine with vertical reflect because it's on the vertical, it's on the outside. But what if the directions say, I want you to reflect it over the blah axis? Is a vertical going over the X or over the Y? Decide, you have to pick a team. Does vertical mean you went over the X, or does vertical mean you went over the Y? Talk to the kid next to you. What is it over? Okay. Vertical is like this. I'm going to show you with a line here. Vertical means up and down. If you have a good vertical leap, you're going up and down. That's going over the X axis. Raise your hand if you knew X. You were correct. Okay. So you just have to draw it out like I just did. If you get your verticals and horizontals confused, horizontal is like the horizon. And vertical is like a vertical leap. You go up and down. Okay. So, oh wait. The only other thing I could really ask you about this graph is to graph it. So I told you yesterday that to make the horizontal, oh wait, do these have a horizontal or vertical asymptote? Let me check for a second. I'm gonna draw it. I'm gonna go, that is what they typically look like. And oh yeah, the asymptote's here. So what kind of asymptote do they have? They have a vertical asymptote. Logs have a vertical asymptote. So what makes the vertical asymptote here? It's something you'd put in on your X and Y chart. I'm going to pause for a second, talk to the kid next to you. What makes the vertical asymptote here? So one of my students offered that whatever makes the inside 0, that is what gives you the asymptote. So 1. Now, take a second, stick 1 in to the equation, and then try to figure out what the answer is. Like, is it an asymptote? It is. Because, Nate, when I put in a 1, what happens? That becomes a 0. Can you even do log base 2 of 0? No, it doesn't exist. Sometimes people get that confused, like that comes out to a number. No, you can't have a 0 here. That's why you get the asymptote. When that hits exactly 0, you have found the asymptote. Okay, now let's find an actual legit point on here. Hallie, can you tell me a number that you've thought about sticking in here besides 1? 2. I agree. That's a good call. Everybody figure out factoring in this negative in this 2 and log base 2 of whatever this is. Like, there's a lot of things to consider. What do you get when you stick in 2? I'll pause for a second while you and your partner talk about what you think the answer is. So, this 2, when I stick it in, gives me a 1 right here. What is special, Greta, about having a 1 right there?
The answer is 0.
Yeah, it's 0. I use that little dumb saying, when you won in the argument, there's a 1 right here, because this is 2 minus 1. Then you won the argument, you get 0. And then 0 times anything is still 0. So 2 comma 0. All right, moving on to the next one. You got to be strategic. You can't just slap in any number. But in this case, the next logical number of 3 actually works pretty well. Because why? Because I stick it in here in my head and I know that this makes this 2. And now I've matched the base. If the base is the same as that base, then the answer is 1. Not just 1 though. You got to times it by negative 2. And so you get negative 2. Who had a negative 2 there before I even said it? All right. If you didn't get how I got that, I stuck a 3 in. And then I did log base 2 of 2. Because 3 minus 1 is 2. Log base 2 of 2 was 1. And 1 times the number in front gives us negative 2. Okay. Do I need any more points? I am sad to report that I am now confident that you have to have 3 points on these. That's going to be the hardest thing. So give me 1 more point. Well, it's not that hard when the base is small. But if you stick in just 4, it's not going to work. Riker, when I stick in 4, why am I saying it's not going to work? Yeah, then I'd have a 4 here, and so then this is log base 2 of 3, and nobody in the room can tell me exactly what that is. It's some weird decimal. So then, since we won't have calculators for this, you'd say, well, I'm not going to use 4, and I'm going to try like 5. Does 5 happen to work? Yes, it does. If you put in 5, now you've got 5 minus 1 is 4, and now you have log, I'm going to be more specific, negative 2 log base 2 of 4. And if you haven't got these exponents down yet, you really have to. That 4 can be 2 squared. So then that means I've matched my base. And now if I make it into a 2 squared, I know that the base is matched, so the answer must be this exponent right there. That 2 is not showing up real well. So the answer to that whole thing is 2. But then I got to times it by negative 2. 2 times the negative 2. You should have had negative 4. Who had negative 4? All right. Is that a cell phone? Oh, good. Sorry. You had classic hand position for cell phone. All right, right in front of the iPad, both hands together, thumbs moving. All right, so anyway, back to a typical question for today then. You could be asked to tell me what happened on this log and then graph it. All right, so would you tell me the two changes that happened to this log? You have to use words like vertical, horizontal, up, down, left, right. And then would you find me 3 points on this equation? And to save time, we're not even going to graph them because I know you know how to graph. Find me 3 points. Oh, and the asymptote. The asymptote and 3 points. I'll pause, wait, try this, and then we're almost done. Like if you understand all I've just told you, then we are getting near the end of our easy day. We just have to look at graphs after that. And once you look at the graph, you'll hopefully be able to say, oh, I can tell that graph's just flipped. Okay, Brooke, tell me, what do you think is a good number to put in? All right, I'll stick in a 1, and then what happens? See if you can do this. 1 minus 4, negative 3. Log base 2 of negative 3 doesn't exist. Does that mean it's the asymptote? No. There's something else would be the asymptote, though. I'll come back to you on a different one. Just stay with me. Anders, what's a good one to put in to get the asymptote?
4.
4. Because why? Because it cancels and makes the inside 0. Whatever makes the inside 0, that's the asymptote. All right. So 4 is the asymptote. So if you made an asymptote like that, see at 4, the whole graph's been moved over 4. All right. So, Brooke, be thinking of another number you think we should put in unless you already have one. Okay, then I'll come back to you in a second. Addie, give me another number that you used besides 4. 5. All right, so we're going to put in 5. I mean, you can do anything you want. It's just whether or not we can figure it out easy. What's 5 minus 4? Ooh, you won the you won the argument, not the asymptote. You won the argument. What's that mean? And therefore, the final answer would be, you put in 5. Nope, I forgot about this. There you go, 5 comma 5. Did anybody else use 5 comma 5? There was lots of options. Okay. All right. Brooke, you got a number yet? 6. We'll try it. So 6 goes in. What's 6 minus 4? What's log base 2 of 2? 1. Now finish it. 1 plus 5 is 6, correct. There we go, 6 comma 6. That's another point. Do we have enough points yet? No. You need the asymptote and 3 points. Okay, so we got to find one more thing to put in. I'm going to pick on Alex. 8, he says. I'm going to try it. I put in an 8 right here. 8 minus 4 is 4. Ooh, you chose wisely because log base 2 of 4 is 2. And then you add the 5 and you get, so you put in what?
8.
And you got 7. There you go. There's another point. Okay, cool. So then I know you know how to graph. You'd have a dot here. 5, 5, 6, 6 is like there. 8, 7. Man, this is weird. Oh no, I'm in the wrong spot. I am graphing those wrong. Okay, sorry about that. And your graph, I'm totally just roughing that out. There is generally where your graph is, because I wanted to just use the points. There's the key. You know how to graph. You know how to graph points. All right, so let's move on to, if they asked you to graph this, I hope your first instinct would be, the asymptote is where? 4. Now, what's this negative in the front gonna do to it? It's gonna reflect it. So wouldn't it normally have been like that? But this moved it 4 to the right. Do you get, generally my graph needs to move to the right 4. So therefore it's gonna generally look like, well, the asymptote's gonna be like 1, 2, 3, 4. there, and so now my graph's kind of over there. You with me so far? But what about this negative in the front? It's a vertical reflect. These are weird to contemplate, but do you get how the green one is a vertical? All right. That's what's hard, is all of a sudden you're like, that doesn't even look like a log anymore. No, it doesn't. It's an upside down log. The blue one is a log. The negative one is still a log graph, but it's got a negative. So that's when we are looking at the graphs instead of like graphing them, which isn't that hard. You make an XY chart, find 3 points in the asymptote. Asymptote would be -5. Oh, wait, there's no base on this one though. Not 10. Log base E in this case. LNs have a base of E. And then how do I imagine E? Well, you get this to be E. And remember how I said E is pretty much 3? All right. So what would make the asymptote? -5 would makes that part 0. And what would make it E? Let's do this one. Just, I want you to find 1 point. We already know the asymptote's at -5. That's easy. If you can assume E is about 3, then you should know how to match the base. If I make this a 1, then I'm going to have a 6 there. No, I don't think that's what you want. You don't want double the base. You want the base squared.
Oh, yeah, because you subtract 3 after.
Oh, I think you were factoring in this. Don't factor in that till the end. So 1 is not a good call because log base 3, I know E isn't 3, but it's close. Log base 3 of 6 doesn't work out nice. -1, he says, with authority. Let's see. -1 plus 5 is 4. Log base 3 of 4? No, I don't like that one. Because log base 3, remember, E is about 3. I'm going to put a squiggly equals about 3. So -1 did not work. Tell me something else. -2 has been nominated. -2 goes in here. -2 plus 5, that's about 3. Yay. We can say that that's pretty much 1. I know it's not perfect, but I'm not going to expect you to be perfect because we're estimating E to be about 3. Now this turned into log base about 3 of 3, because that's what -2 plus 5 is, and then -3. Well, this part is about 1, -3, -2. And we stuck in -2 in the first place. There is a point on this graph. It has been suggested I put in 4 by a student. I agree, because that's about 9 then. And so then this 3 and this 9 about work out to about 2, because 9 is like 3 squared. And so that's basically 2. 2 minus 3, -1. So I put in 4 and I get -1. So remember, when you're doing your E's, you're saying it's about 3. And so these answers are all about, and I don't need the graphs to be perfect on E. Nobody is going to be able to perfectly graph E anyways. It's just how far off are you. So if you estimate that it's about 3 but a little less, these answers will be a little less than whenever they are. So when you graph them, just make them a little less than that. All right, I want to get to the kind where they give you an equation, and I think that this isn't as easy as you might think. That doesn't even look like a log. But can you picture it, that it might be a flipped over log? So then which of these answers is it? Well, there's a bunch of ones that have negatives in it. So it must be one of those, but then there's obviously only one right way to do it. Now, I come down to it can't be this one because it has to have a negative because it's flipped. The next one, could it be that? Well, maybe, because that is a vertical flip. Would you agree that this is a vertical flip? It's like a this way flip. See what I mean? So if it's a vertical flip, it can't be that one because that'd be a horizontal flip. So now we're down to 2, but I'm not sure which of these 2 it is. Imagine it's the test. How would you pick between B and D? With points, yes. So if you knew that you thought it's this, then you'd be able to make your little chart and go, where's the asymptote? Well, the asymptote's at 0, and that's the same for both of them, so that doesn't really help. What's another point I could pick? Well, if I stuck in 1, I won the argument, and I get 0. Do these both go through 1? No, not both. Does this one go through 1, 0? Yep. Does this one, if I stick in a 1 right here, does it also go through 1, 0? It does. So, do either of those two go through, stick in 1, and get 0? Well, 1, 0 is that point right there. They both would have that point. So again, that didn't fix it for me. They both have 1, 0 on them. So either this one or this one would have had 1, 0 on it. I got to find a different point. How about 2? If I stick in 2 in this one, that works nice. If I stick in 2 on this one, but it has no base, Mr. Server. Oh, but it does have a base. What's the base? Base 10. And now this would tell me that 2 should give me -1. And as I look at this graph, 2 and -1, it's not touching -1. It should be touching right there if it was going to be that one. So it's got to be this base 10 one. The way you can also tell is this thing has turned super sharp. Like if I do a really careful reflection on this thing, that's the reflection. It's a super sharp turned log, and that means the base was big. All right, but bottom line, you would find it with points. I could narrow it down to 2 of them pretty easy, but I'd find it with points. Let's do the last couple slides here, and we're almost done. Keep your focus with me. I know it's the spring. It's harder to focus. We're almost done. This one, would you agree it generally looks like a log, so it hasn't been flipped? Does that make sense to you? Mm-hmm. So it's generally a log. Has it been moved left or right? Yeah. Yes, that should narrow it down. Start narrowing it down to which one it must be. It is a log. It's not a flipped log, so there's no negatives. Well, I guess there wasn't any anyways. But it's been moved left 3. Ooh, I know which one it is. Boom, it's A. Because that's the one moved left 3, right? If you weren't sure, you make an XY chart and you see if it follows. Like when I stick in -3, I get the asymptote. Well, that was, yeah, that works. If I stick in -3, I get the asymptote. And if I stick in like 1 right here, I'd have log base 2 of 4, which is 2, 1, 2. It goes through 1, 2. I'm feeling pretty good about A. 1, no help. Pick if it's A, B, C, or D. Don't say it out loud. Choose A, B, C, or D. Circle it. And then one of the bad things about sharing with your neighbors, as soon as the one kid with a loud voice says, it's A, or whatever, then everybody thinks they know the answer. Okay, so just circle which one you think it is, and then silently compare with the kid next to you for a few seconds here. I'm going to pause. It's our last one. All right, one of my students says it is B. I'm going to check. Well, first off, the asymptote is definitely moved over. And unless I wanted to argue that the asymptote is like at 0.9, I think the asymptote's at 1. That means it's been moved over 1. That one hasn't been moved over 1, but all 3 of these have. So you think it's B. I'm going to check. It's hard to know for sure unless I check points. Hallie, would you tell me one point I should check? I'm going to put in 1. If I put in a 1, I do get a 0 on the inside. That is the asymptote. That point checks out. Give me another point. 2. I put in 2. 2 minus 1 is 1. I won the argument. I get 0. 2, 0. Does that match up? 2, 0? 2, 0 isn't on there. It's not that one. If I know I'm looking for a right equation now, I'm going to try one of these other ones. It's got to be one of these two. what's the difference between these two? Well, one's got a base 3 and one's got a base 2. Again, I'm going to look for points. They both have the 1 for the asymptote, so that's good. Nate, do you have a theory which one it is, C or D?
I said B, so I don't know.
Okay, all right, then you have to struggle with me too then. Let's try and find another point, but let's assume for a second it might be this one. So find a point on it and let's see if it matches.
4.
Okay, we put in a 4. And if I put in a 4 here, I have log base 3 of 3. Yay! And now what's that equal to? 1 plus 2, 4 comma 3. Does that match up with the graph? 4 comma 3 right there. Boom, nailed it. I think that's probably it. Does that make sense? If I wanted to check if this was it, look what happens when I put in a 4. 4 minus 1 is 3. Log base 2 of 3? That doesn't even work nice. But on the graph, it actually does. See? 4 comma 3 is a real spot. It's definitely C. Nate got it by pure luck. Oh, you had to guess between those two. But you guessed, and you guessed right. We verified it through checking points. Remember this on the test. Don't just be like, oh, I think this one's it. Because you can get fooled really easy between like C and D. You got to check points. All right, that's all I got for you for today. So let's turn to the homework. I suppose I should tell the kids at home that are not here today and watching this which ones to do on the homework, because I always skip some. In the directions of the worksheet, I think it says problems this, this, and this. 2, 3, 4. That sounds very reasonable. If you haven't noticed, your homework assignments have been smaller and smaller. Why? Because it's the spring and it's harder and harder to get you guys to do anything. So if we keep it small enough, hopefully you'll keep doing them. And if you keep doing them, you'll definitely see a difference on your tests. Try stopping homework for a week and see what happens on your tests. It's not good. For those of you that have been surviving that way, congratulations, you have special skills. Usually it takes some homework to make it stick.